Hello and good day, Algebra. We are once again climbing the ladder of polynomial expressions here. We started with addition and subtraction. We then went to multiplying a monomial by a polynomial, so 1 by anything. We then went to 2 by 2, binomial times binomial. And now we are multiplying anything. All bets are off, all the safety guards. Any size polynomial times any size polynomial. Yeah.
Is this like a test grade or is it a quiz grade?
It goes down as a test grade.
What?
This was?
Yes.
So,
So,
Alex, use our book.
3, 2, 1, you are quiet. Thank you. Yes, Alex.
How long do we get?
Period.
30 minutes. But then we have homework. But then we have homework.
Let's talk about it later when we're not recording for this, okay? Okay, so this first one that we have here is a 2 by 3, and essentially the distributive property, which has kind of been the theme for any multiplication here, is still in play, right? When we had a single term outside, we just distributed it into the parentheses, and we were all good, okay? When we had a binomial times a binomial, we were doing the same thing, but we had little fancy names for it. We had old man foil, we had crab claw. We were basically making sure that every term in each expression was multiplied by every term in the other one. Same thing here. The problem though is that when you get to like a 2 by 3, 7x times 2x squared, 7x times 4x, 7x times 1, negative 4 times 2x squared. It's like a mega crab claw. Okay. When you get down to a 3 by 3, things get even. We're going up top. We're going to every term in the other expression. Now we go to the 4x squared and do that there. And now we got this negative 5x. How do we do this? Things just get chaotic. Okay. So we're going to a new method here that will work for any type of multiplication you want to do. Have you done Punnett Squares in science yet?
Yes.
Nope. Someone wasn't paying attention. Whoever said nope. Okay. These are just like Punnett Squares. Okay. In the sense that when you've got a 2-term expression times a 3-term expression, you're going to make a 2 by 3 box. So go ahead and in this space, you got plenty of space to write here. Make a big 2 by 3 box. Okay. You don't want to leave yourself too little space in the squares inside the box. Because if you have to scrunch these terms in here, that's when 2's start to look like 3's and negative signs get missed. And so leave yourself plenty of space to write here. Okay? Don't fill up the whole area because we're going to write stuff below here too. Okay? Basically, whatever I do up here, you want to do the same thing. That's kind of I left some space there. Right? That is okay, Christopher. What you have there is fine. Right? Good. What you have there is fine. Yes. And across the top here, where we have our 3 squares, we're going to be writing our 3 terms. 2x squared, 4x, and 1. Okay? And then down the side, we'll go our 7x and our negative 4. Right? We use a 2 by 3 box because we have a 2 by 3 expression here. And then what goes inside each of the boxes is the product of the 2 terms that intersect there. So this first one, this upper left one, will be the product of 2x squared and 7x, which is 14x cubed. Okay? Why is it cubed? Because you have a 2x squared and a 7x. The next one over, 7x times 4x. 28x squared. And the next one over, 7x times 1, 7x. So essentially what we did is we just distributed this 7x into each term in the other set without drawing the lines and getting all confused with what goes where. Okay, this is a very organized method to multiply these. Now we go to the negative 4, and we also multiply that by 2x squared, which is negative 8x squared. We multiply negative 4 by 4x, which is negative 16x. And we multiply negative 4 by 1 to get negative 4. So the first step is to fill in our box here with the products of the terms that intersect each of the squares. Now, we have to put our answer all together. We have to write it in standard form and combine any like terms we have. So we look at what we have inside the box, and we only have one x cubed term, right? We have two x squared terms, though. They can be combined. We have two x terms. They can be combined. And then we only have the one constant. So our final answer is going to be 14x cubed. How many x squareds? 20. 28 minus 8. My exponent does not change now because I'm adding and subtracting, right? I've switched operations, so the rules change slightly also. The exponents change when you multiply, but not when you add or subtract. How many x's? 9. Negative 16 plus 7. And then my constant of -4. And that is my answer. Okay? So I've seen this particular concept be very, very challenging for folks who don't lay it out in an organized way. Miss exponents, miss signs, they try and work too quickly. Okay, take your time with this. Take your time with this. I mean, even one little itsy bitsy mistake anywhere in this process, and your answer's going to be off. All right? Your answers are going to be off. Let's do the next one. Another 2 by 3. So we'll make our box here. Okay? 3 across, 2 going down. William and Ellen, is that you? 2 talking? Or for each of you? Quiet. So we have 3x squared minus 4x plus 5 going across the top. And we have 8x squared and 10 going down the side. And now we just fill it in, right? 3x squared times 8x squared, 24x to the 4th. 8x squared times -4x is a -32x cubed. 8x squared times 5 is 40x squared. And now the 10, multiply that by everything in the other set. So 10 times 3x squared is 30x squared. 10 times -4 is -40x. And 10 times 5 is 50. Okay. Are there any like terms you can combine?
No.
Aiden.
30x squared and 40x squared.
Yes, we've got these two here. And that's it. Okay? Your like terms won't always line up nice and diagonal here. The reason why these did is because both these are in standard form without any open terms. But here, because we skipped that x term there, that 8x squared plus 10, it kind of throws off that diagonalness a little bit. But the like terms are still in there. So final answer, 24x to the 4th minus 32x cubed plus 70x squared minus 40x plus 50. Another one of those things that I think looks a lot worse than it actually is once you understand the setup. The math behind this isn't particularly challenging in the sense that it's, basic multiplication facts if you understand how powers work, okay? But it's the setup that is key here. If you're just trying to attack this without any plan, it is a very challenging thing. Okay? Questions so far? Not too bad, huh? Okay, let's do one of the ones below. We've got 2 3 by 3. Which one do you want to do?
First one.
First one, all right. So we have a trinomial times a trinomial, so we have a 3 by 3 box here. Okay. It does not matter which expression goes across the top, and which one goes down at the side. It'll work out the same either way. So 3x cubed, 4x squared, negative 5x, 10x cubed, 8x squared, and 6x down the side there. Raise your hand and tell me what the top left product is going to be. Vince.
30x.
30x to the sixth. Good. Next one over. Joey.
24x to the fifth.
You went down. Okay. Going down, 24x to the fifth.
Oh.
Ooh, you could give me an answer. I could guess which box it belongs to. Wouldn't that be fun?
Do it.
Oh,
Alex.
No.
24x to the third.
24x to the third.
Oh no.
Oh, here we go. Here we go. 24x cubed. Claire?
Negative 30x squared.
Negative 30x squared. That's going to be over here. Okay. Bryn?
Negative 40x cubed.
Negative 40x cubed. Next, that's got to be with the 5. Okay, good. Negative 40x cubed. Will, do you want to play?
No, I have a question.
No, not you. Catherine.
I have a question.
Oh, yeah.
Does it matter like what side you put on like when you're doing the table?
No, it does not. Yeah.
Isn't the second equation on the top like the 10x and the 8x?
It doesn't make a difference. Whether you put, it does not matter which expression goes on which side of the box, because you'll ultimately get the same result anyway. Right? Aiden.
32x to the fourth.
32x to the fourth, that's our middle square. Take that go. Alex.
18x to the fourth.
18x to the fourth. What a brilliant game idea. Have you played tic-tac-toe with 3x3
We have enough.
polynomials?
We have enough practice as it is.
You have to give the answer, and that's where you get to check off the box. Brilliant. Wow. 40x to the fifth and negative 50x to the fourth. Woo! Okay. Now, because these were written in standard form without any open terms, our combinable terms, our like terms, are quite obvious. Okay. They again kind of line up diagonally. We have an x to the fifth and x to the fifth. We have 3x to the fourths right through the middle here, and then we have 2x cubes. Right? Now we're switching operations to combine these. We're going to addition and subtraction. So we have 30x to the sixth, 40x to the fifth, and 24x to the fifth, the positive 64x to the fifth. 18, 32, and negative, well, that's nifty.
They cancel out.
They cancel out completely. 18, 32, and negative 50 is 0. So our x to the fourth terms are completely gone. And then negative 40 and 24 is a negative 16x cubed. And then negative 30x squared. Okay? Good stuff.
Alright, can we do one more?
Good stuff.
How'd
Lisa,
you get the 64?
by combining 40x to the fifth and 24x to the fifth, those like terms, those same variables, the same power. Okay. Is there one on the second page you'd like to do together? You do, but it's not due until Thursday, so you have an extra day. Rowan, the last one. What type of box is that? Is it a
It's
3x3?
It's 3x3.
3x3? That's not too shabby. Hey?
So you should know the first one. Oh.
The first one's
2
easy.
by 4.
Yeah, they're all easy. We're just not done with this one.
Once you get the setup, like I said, then yeah, it's kind of just pay attention to those signs, pay attention to powers. 8x squared, negative 12x, negative 8, 2x squared, negative 3x, and 2. Okay. I like how the like terms are going to line up for this one also. I'm seeing both expressions are in standard form, no open terms, so it's going to work out nicely. ax squared and 2x squared is 16x to the fourth. Then we got negative 24x cubed, negative 16x squared. Now we go to that negative 3x multiplied by everything in the other expression. Negative 24x cubed, 36x squared, 24x. And that constant of 2 multiplied by everything in the other expression, 16x squared, negative 24x, negative 16. Our like terms line up diagonally just like they're supposed to, right? Since we have these the way these expressions are set up. So we got our x cubed terms, we have our x squared terms, and our x terms. Our x terms do cancel out. Good job. Okay. But our x to the fourth term, nothing to combine that with, so 16x to the fourth. Our x cubed terms, it seems like they might cancel out if you're working too quickly and not really analyzing it, but what do we get in actuality? Negative 48 x cubed. Negative 24 minus 24. Our x squared terms, so that's interesting. We have two of them that cancel out, our 16 and negative 16x squared. So we're left with 36x squared. Our 24x's do cancel out since one's positive and one's negative. And then our negative 16, our constant, just hangs along. Okay. Questions on the box method? Okay. For those of you that have trouble memorizing multiple ways to do something or multiple methods, the box method will also, look, we're doing Punnett Squares.
Punnett Squares.
The box method,
Square?
kinda.
Kinda.
It's the concept.
It's kinda.
Yeah.
Matter of fact,
Yeah.
it's exactly like a Punnett
Yeah.
Square.
The box method will also work for binomials. If you don't like old man foil, if you don't like crab claw, you can make a 2x2. So you have 2x minus 8, 3x, and 1. Right? And you're just filling in the boxes here. Normally, when we draw the line for 2x times 3x, now we just fill in the box. When we draw the line for 2x times 1, now we just fill in the box. Negative 8 times 3x, negative 24x, negative 8 times 1, negative 8. Right? So it's just another method. If you like the box method, if you like how organized it is, whatever, you can use it for a binomial times a binomial also. Combining like terms, 6x squared minus 22x minus 8. Okay? Yes, Aiden.
So back pages and homework.
Yes, the whole thing's homework.
Oh.
Yeah, but do Thursday, since tomorrow you have your quiz and stuff. So it's a little lengthy, but there you have it.
Like, we turned it down.
Well, you don't ever really turn it in, but
Can you check this
I will look at it. I'm not gonna check it out. So I'll look at
Just
it.
to make sure we don't forget about Thursday.
Oh, what? Yeah, I'm not gonna be here on Thursday.
Sure. All right. Anything else? Questions, comments, concerns, complaints, comments, congratulations, criticisms? Yes.
Not sure.
Thank you. Anything else?
You forgot to wear your shorts today.
I'm not being observed today. I'm going to wear them for my observation day.
Can you do it like the day after spring?
Shorts with suspenders and a flower tie.
No. Shorts
Yeah.
with
No,
suspenders
April-
with a yellow top and
April
a
12th.
flower.
April 12th.
Okay,
Is
you
my
better not
obvious.
forget.
I probably will.
Or
Oh.
like a
Thank you for the
white.
last answer.
What's that?
Thank you for the last answer.
Anytime. All right.
Do like 3 more.
Homework due Thursday. That's a math.
Don't forget to like and subscribe.
Where's my little? Oh, here.